Good morning. I am Riya Baby and I hope you are all energetic and motivated for today's section. So let's move on to the section. Consider the example. Today, during my morning walk, I saw something glowing at the top of a tree. I am very curious about that. I need to reach the top of the tree, so I need a ladder, but I am not sure what length ladder should I buy because I don't know the height of that tree. Can you help me to find the height of that tree? Do you have any ideas about it? This is what we are going to discuss in today's section. There is a branch of mathematics that helps us to solve these kinds of situations, and that is called trigonometric ratios. Before going to trigonometric ratios, you should be familiar with the word trigonometry. Trigonometry means this is the combination of two Greek words, trigono and metron. Trigono means triangle and metron means measurement. Trigono, three sides. So this trigonometry is the study of measurement of a triangle. So this is a branch of mathematics that help us to find the relationship between the angles and the sides of a triangle. We can apply trigonometry to any kind of triangles, but now we are focusing on right angle. So now consider a right angled triangle RST. So right angled triangle means the largest angle in that triangle is 90 degree, and we all know that the side opposite to 90 degree is called hypotenuse, and we can select any one of this acute angle. Now I am selecting this acute angle as a theta t, angle t as a theta. Then the line that ends with these two angles is called the baseline and the other is called the perpendicular line. Now if we consider theta as this angle r, then RS will be the baseline and ST will be the perpendicular line. So this theta determines the sides of a triangle. So this is about of a right angled triangle, and you all are familiar with the famous Pythagoras theorem, hypotenuse square equals base square plus perpendicular square. Now we can denote hypotenuse as h, base as a b and perpendicular as a p. Now we are going to deal with the trigonometric ratios. Ratio means ratio of the sides related to our selected theta. So how can you say how many ratios can be made of these sides of the triangle? We can make ratios perpendicular. These are the sides are perpendicular, hypotenuse and base. So we can make the ratios as perpendicular by hypotenuse. This is one ratio, and we can take base by hypotenuse. This is another ratio. Also we can make perpendicular by base. This is also another ratio. This ratio according to this particular theta is named as perpendicular by hypotenuse is named as sine theta. Base by hypotenuse is named as cos theta. Perpendicular by base is named as tan theta. These are the important trigonometric ratios. So sin theta is defined as P by H. Cos theta is base by hypotenuse. Tan theta is P by B. Also, you can find other ratios from this right angled triangle. That is, here we have taken perpendicular by hypotenuse. So we can take hypotenuse by perpendicular also we can take. So that ratio is called cosec theta. Another one is reciprocal of this one. Hypotenuse by base, that is called sec theta. And next one is base by perpendicular, and that is called cot theta. So from this it is clear that sin theta, cosec theta is the inverse of a sin theta. Inverse of sin theta, that is P by H. Reciprocal of sin theta is cosec theta. So cosec theta can be written as 1 by sin theta. Here this is the reciprocal of cos theta. So we can write it as 1 by cos theta. Here cot theta is the reciprocal of tan theta. So we can write it as 1 by tan theta. So these are the important ratios, trigonometric ratios, that is sin theta, cos theta, tan theta, cosec theta, sec theta and cot theta. Okay, now So now come to the example that I am showed you earlier. So to find the height of that tree, now consider this as a triangle, right angle triangle. Since the tree is standing in the ground, we can select this as a 90-degree, and we can select this as our acute angle. This is a hypotenuse, this is our baseline, and this is our perpendicular line. So to find the perpendicular of this triangle will give the height of that tree. So by using these trigonometric ratios, we can easily find the height of this tree. So this is our today's section, and I hope you all understand well, and thank you for your listening. Thank you so much.